Hmm. Hi all. So today we'll be learning about IP fragmentation. So this is not an anatomy of how the IP packet format looks like, but I will just give you a brief overview so that you can understand the rest of the lecture. So so let me first of all tell you the problem. So at network layer, as you can see, network layer, so the IP protocol is implemented at network layer. Okay, so it attaches a header to whatever data that it receives from the transport layer above. Okay, uh, so whatever it receives from the transport layer is this one, and the rest is the header that is attached by the protocol at network layer. So the IP protocol is implemented at network layer. Okay. Now this packet at network layer is termed as datagram. So now datagram, this is also called MTU, that is maximal transmission unit. Now what does it mean? So suppose this is your network. So this network has a MTU with itself. Okay. So for example, it says that I can accept only uh, 200 bytes of data at network layer. Okay, so whenever data is received by a host, okay, whenever data is received, it goes from physical layer, data link layer to network layer. So at network layer, MTU says that I can only receive 200 bytes of data at here. If the data is more than 200 bytes, even if it is 201 bytes, then this packet will be discarded and not received by the receiver. Okay, so that is MTU. So now let's see what's the problem. So suppose this is the sender's network, okay, and the sender's network MTU is uh, is 520 bytes. Okay, is 520 bytes. So this is MTU. And what is MTU? This is the size of packet at network layer. Okay, this is the size of packet at network layer. Now this packet is prepared by the sender host and it sends through router to another network host, and this network host, uh, this network has a MTU defined of 200 bytes only. Okay, but the sender has sent 520 bytes. So when the packet reach to router will discard it. Okay, it says the network that the recipients, that the destination host cannot accept the packet which is more than 200 bytes at network layer. Okay, so that's the problem. Therefore, now comes the IP fragmentation. So at net, since the sender is sending 520 bytes, it so now the router uh, will divide the data into smaller packets so that the destination host can accept the packet. Destination host can accept the packet. Okay, now how does it do that? So first of all, let's see that there that in the flags. So there is a flag in which there is a do not fragment bit. Okay, do not fragment bit. If this is set to 0, that means we are allowing the router to fragment our packets. But if it is set to 1, okay, if it is set to 1, then we are not allowing the router to fragment the packet. So when a packet comes at router, it's the router's decision, it's the router responsibility to divide the packet into smaller chunks so that the destination can accept that packet. But it is the responsibility of sender to set this bit, and router cannot by itself decide if it wants to divide the packet or not. It checks the DNF bit from IP header. Okay, it's checked that bit, and if that bit allows it to fragment, then only it can fragment the IP packet, which is the datagram. Okay. uh, yeah, so now let's see. So this is the 520 bytes data, and let's see, 500 bytes is the data and 20 bytes is the IP header. Okay, that is attached by the sender. Now this has reached to router. So now the target is 180 bytes of data and 20 bytes of header. Okay, this forms a total 200 bytes. So now router will divide the data, divide the payload. This is the payload. Router will divide the payload. So from 500, it will divide. So as you can see, the maximum acceptable unit is 180 bytes. So it will divide into 180 byte, 180 bytes, and the remaining ones. So 500, 360. Okay, 140 bytes. So the last packet is 140 bytes. So now there will be three packets. One is 180 bytes and 20 bytes header. So the same header, this same header is put here, and similarly this 180 bytes data and 20 bytes header, and here also 140 bytes data and 20 bytes header. Okay, now these three packets will one by one go to the destination. Okay, now one more thing. So how does the destination know? How does it know that which packet is to accept first? So we know that this is the first packet, okay, and then this is second, and this is third. So this is a particular sequence. If you jumble that sequence, then your whole data will get intermixed. Okay, so therefore there is a field in IP header which is fragment offset. Okay, fragment offset, and one more field which is more fragments. Okay, this is basically a boolean field, and fragment offset. So more fragment means, so for example, this is our first packet. Okay, so it says yes, there are more fragments that are coming behind me, so it will set this bit to 1. And now the second fragment will say yes, there is one more fragment which is coming behind me, so it will also set to 1. And the fragment 3 is the last fragment, there is no fragment coming behind it, so it sets the bit to 0. There is no more fragment. Now what is fragment offset? It says how many bits, sorry, how many bytes have already ahead me, how many bytes are already ahead me. So for the first fragment, this is the first fragment, there are no bytes that are already sent. So for this it is 0. And for the second fragment, how many bytes have already sent? So as you can see here, 180 bytes has already been sent. Okay, so to be noted that it does not use the header here. It only mentions the payload that is already been sent. And the third fragment says, so 180 for the second fragment and 180 for the first fragment. So a total of 360 bytes of payload has already been sent. So this way fragment offset and more fragment work. So now there is a problem. As you can see here, the fragment offset is 13 bits. Okay, so the fragment offset is only 13 bits. That means it can represent 2 raised to the power 31 minus 1, that is 8191. So there can be 1, 2, 3, 4, and up to 8191. These are the different numbers can be put in fragment offset field. But the maximum payload in a fragment that can be there with, this is 65515 bytes. Okay, so according to the fragment offset field, the maximum number that can be present there, it is 8191. but but the fragment that has already been sent can have 65515 bytes of payload plus 20 bytes of header. Okay, So this is a fragment that has already sent, and this fragment's payload can have 65515 bytes of data of payload. Okay, but in the fragment offset field, as you can see, because of the limitation to the number of bits present, it can only represent that only 8191 bytes of data has been sent. Okay, so this is a misconfiguration. Okay, this can't work. So in this case, we use a concept called scaling. Okay, we use a concept called scaling. So I will just give you a very short example. So in a map, you see that the distances are shown uh, with scale. There is a scale mentioned. For example, 1 centimeter represents 1000 kilometers. Okay, so these type of scales are mentioned in a map. Okay, so similarly here we will do. So as you can see, the maximum number that I can mention in the fragment offset field and the maximum payload that can go in the fragment, these are 65515. Okay, so that means if I mention in the fragment offset 8191, that doesn't mean that there are 8191 bytes of data has been sent, but it means 65515 bytes of data has been sent. So from here we can see, if I mention 1 in the fragment offset, that means 65515 divided by 8191. So it is 8 bytes of data. Okay, so now see. So now if there are two fragments, and if there is a 8 bytes of data already sent, 20 bytes of header, and this is the first fragment, this is the second fragment. So the fragment offset for the second one will be 1. Okay, in the header we will mention it 1, because 1 represents 8 bytes of data. And how many bytes of data has been sent? 8 bytes of data. So let's take another example. So if the first fragment had let's say 32 bytes of data, 20 bytes of header, this is the second fragment. So fragment offset for the second one will be 4. Okay, it will be 4, because as you can see, for 1 it is 8 bytes, for 2 it will be 16 bytes, for 3 it will be 24 bytes, for 4 it will be 32 bytes. Okay, this will go on. So this is the scaling. That is, whatever you are mentioning, that doesn't mean that 1 bytes of data has been sent. No, 2 doesn't mean 2 bytes of data has been sent. 2 means 16 bytes of data has been sent. Okay, so now let's come back to our original problem, in which the sender has 520 bytes of MTU and the receiver has only 200 bytes. Okay, so let's see. So the sender had 520 and the receiver had 180 and 20. Okay, so now it is the responsibility of router to divide the packet. So what it will do, 500 will be divided into so 180 is the acceptable maximum acceptable payload. So it will see if it is divisible by 8 or not, because you can see here that that it is a multiple of 8, 8, 16, 24, 32. These are only multiples of 8. Therefore the payload here sorry, in the fragments, so this is a fragment. Okay, in a fragment the payload can be a multiple of 8 only. Okay, so therefore we will see if it is divisible by 8 or not. So 16, no, it is not divisible. 4 is extra, so that means the fragment will have 180 minus 4, that is 176. Okay, now 176 is divisible. So now let's see. for 176, what will be the fragment offset? So 8 to 16, 8 to 16. So it is 22. Okay. So now comes the second fragment. Similarly, second fragment will have 176 bytes of data, payload. So how much is left? 176 2 15 352, and the total we had was 500. So 894 and 248. uh, so it is 148. Yeah. So now the third fragment will have 148 bytes of data and 20 bytes of header. So now these are the three segments. Okay, the router has made these three segments. Okay, this is your first segment, this is second, and this is third. So now let's see the fragment offset and more fragments. So for this, for first packet, more fragments. Yes, this is true. For second packet, yes, there is. For second fragment, yes, there is a third fragment that is upcoming. So it is also true. And for this is false because this is the last fragment. There is no fragments coming behind. Now let's see fragment offset. So fragment offset means how many bytes of payload have been already sent. So for the first fragment, there is no fragment uh, ahead of it. So it is 0. How many fragments, how many bytes are ahead of fragment 2? So this is 176. So for 176, we will have to say 22. Okay. And similarly for the third fragment, so 176 for the second and 176 for the first. So this is 352. So now how will we write it in fragment offset? Divide by 8. So 8 4 32, 8 4 so 44. So for the fragment offset will be 44. So now these three packets one by one. So first fragment will go, then second, and then third. Okay. So this is how a router basically divides your whole packet into multiple fragments so that the target network can accept your uh, packet. And please remember that the MTU means the total size of the packet that is generated by network layer. Okay, so it includes both network layer header plus network layer payload. Okay, so if the MTU is 200 bytes, then it means uh, 20 bytes of header and 180 bytes of payload. Okay, the header can also be different because as you can see here, the header can be so this is header can be 20 to 60 bytes. Okay, because in header there is a field called options and it is variable. Okay, so anyways, that is the different thing, but just keep in mind that 20 bits is the minimum header size. It can also extend up to 60 bytes, but accordingly the payload size will also change. Okay, so yeah, that's it for the lecture. I hope you have understood about how fragmentation works.